Hello, in this video we're going to be talking about the general information for the plasma membrane. So let's not waste any of your time, let's get right to it. Now when we're talking plasma membrane, we've got to be talking about the components of the membrane. That's the superimposed part. It's almost like a car. I mean, you can say that it's a Ford or Dodge or a Ram, but really it's a collection of individual parts, all designed to complete their own function. And when each of them completes their own function, the whole thing works efficiently. If one of them isn't completing its function, just like on your car, if the battery is not doing its function, the spark plugs aren't doing their function, or the pistons aren't doing their function, the alternator, if those things aren't doing their individual function, then the whole thing is affected overall. And the same with the membrane. It's a collection of components, and because of that, they use the phrase fluid mosaic model when talking about the membrane, and that's just simply a way to try to depict the complexity of the molecule. Even though it's an organelle that's microscopic small, I mean, it's a super complex collection of components, so much so that not only does it mentioned here, we've talked about it in the organelles, chapter 4. We talked about phospholipid in chapter 3. It has its own chapter, and which is this one right here, plasma membrane. So super important organelle, and we're going to go through and talk about some of the things. You can see the image there beside me. I mean, we got the proteins that are meant to be gateways, and not only are they gateways, but as we go through this unit talking about diffusion and osmosis and facilitated diffusion and active transport, there are a variety of proteins, each with a different function. I mean, maybe a protein is just simply a pathway for whatever coming along, like with diffusion. It could be a protein that's designed just for one particular ion or one particular molecule. And if that's the case, it'll have little receptors on it that those ions, those molecules, have to be identified in order for them to use that particular pathway. They could be surface proteins. Surface proteins are a huge part of the immune system because they're designed to recognize what something is before anything happens. That way, if it's determined that it's a foreign material, then the immune system is alerted and can come in and help clean up the mess. It's got cholesterol. You know, we hear a lot about cholesterol, good cholesterol, bad cholesterol, but your body makes cholesterol, as we looked at when we talked about carbohydrates, or macromolecules. So it makes what you need, and it's got a particular purpose, as we'll talk about the cholesterols. Make the membrane a more firm membrane. It's got the phospholipids that I mentioned with that polar head and those nonpolar tails. Those tails are super important because with the double bond and the unsaturated fats, it allows more fluidity through the membrane. If it was just straight saturated fats only, then it would be a situation where it'd be too packed in and things would have trouble getting through, like water, oxygen, carbon dioxide, that kind of stuff. So there's a lot going on in the membrane. As I mentioned, this fluid mosaic model, as it says there, and I mentioned, it's used to help to kind of describe the components and how they work together to make this. But what it speaks to is the fluidity and the flexibility of the plasma membrane. The plasma membrane has to be able to adjust to all kinds of scenarios through the process of diffusion of just things coming in and out in opposite directions and moving around. But it's got to be ready for any kind of a transport. Bulk transport, when we talk about that, when part of the membrane is used to bring things in or to exit materials, vesicles can become part of the membrane. Part of the membrane could pinch off and become a vesicle. But active transport with use of ATP, the proteins have to open and close. And so the membrane just has to be pretty flexible. If you think about your door, I just glanced at the door here in my office. If the door opened and closed, not with a door opening, but with the area shrinking and opening so you could enter, just think about how flexible the walls would have to be in order to close with it and then to push back when it opens up. That's kind of an idea of what the membrane has to do. So it's got to be pretty flexible, because the variety of transport mechanisms really causes that. Okay, now when we're talking the structure and the functions, it's got four main components. It's got that phospholipid bilayer, which has to be a super flexible that I've mentioned, but it's also a barrier. Okay, the membrane is semi-permeable, which means things can go through it. Okay, but the semi refers to the fact that the membrane decides. It's not just the membrane; it's the components, proteins that have those receptors on them, the glycos that we'll talk about, the glycoproteins, the glycolipids that are part of the recognition process. So a lot goes into play. So if a bacteria cell shows up, okay, it just didn't get automatic entrance. It's got to go through some checks and balances, some identification process, and of course the immune system is set up to recognize that foreign material and to take it out with those cell surface markers, as I mentioned, the glycos. You've got proteins, and each of these components have their own little video that will go deeper into that. But you could have proteins that span the entire width of the membrane. You could have surface proteins. You can have proteins on the inside for things that need to get out. Just the thing to recognize, it's super flexible, super fluidity, nothing as far as going through, but it's also not symmetrical. Okay, the top layer, or that faces the outside of the cell, is not the same as the layer on the inside of the cell. We talked about cytoskeleton stuff and extracellular matrix stuff in our last video series. Those create some differences. The different proteins, there won't be any glyco stuff on the inside, so it's not identical on the outside as it is to the inside. But just to make sure that you are getting the components and their functions, the function component connection, that'll come up obviously in some test questions and quizzes and stuff. But the proteins, they're gateways, okay, for transport, but they're also part of the molecule recognition. In other words, it has to determine, hey, is that something that was made by us? Okay, is that us, or is it foreign material? The cholesterols deal with making the plasma membrane less fluid, more dense, and of course the glycos help with the immune system. The glycoproteins are, let me start with the glycolipids. They're the ones that recognize, okay, if that's foreign material or not. And the glycoproteins, they're the ones that alert the immune system. So it's kind of a tandem, working tandem. One recognizes the glycolipids and one alerts the glycoproteins. Well, that's our video on the general information of proteins. When we come back next time, we'll be talking about phospholipids. We'll see you then.